we go, part 2 of my Parabola series. Talking about conic sections. In part 1 I introduced the conic sections and went through a few examples on how to find the focus, the vertex, the directrix. So in this part 2 we're going to basically go through a few more examples and see if we can't make some more sense of this. A lot of this stuff with conics, since some of the equations are so similar, it's really all about practice. Just practice the heck out of these things and you'll get better at them. So here we go. We have our first example here. We want to find the focus of the parabola with a vertex at -5, 2. It opens vertically and passes through a given point. So here we go. Let's put our focus, let's put our vertex there first. So -5, 1, 2, 3, 4, 5, +2 is over here. That's our vertex. It opens vertically and passes through -3, 0. So let's think about this. If the vertex is up here and it passes through down here, that means that of course it's going to open down. So let's try to connect these dots. It's going to be symmetrical, which that is not, but something like this. So there's our general sketch of this thing. Now the vertex form of a parabola is right here. A parabola that opens up and down anyway, where A is sort of the coefficient that tells us which way it opens, up or down, and how wide that opening is. So this, of course, we know is going to be a -A because it opens down. So we'll keep that in mind in a few seconds here when we actually find our A. But before we do that, let's actually put in our H and our K into our vertex form. So we have Y is equal to whatever A is, X minus H, so it's minus, I'll simplify that right now, it's +5 quantity squared +2. And we need to find that A value first, so let's actually plug this point in too. This point can get plugged in as X, Y. So we have 0 is equal to A, X is -3 +5 quantity squared +2. And let's solve this for A. So this is 2 squared +2. So we'll move this 2 over and we get -2 is equal to 4A. So that means our A value is -2 over 4, -1/2. Alright, and that can be, I'll put that right here, that can be inserted now as our lead coefficient in our equation. So this is our equation to our parabola. And again, it opens down, so that should trigger for us that the A value is negative. It is, that's a good thing. And this one's going to be a little bit wider than normal. The normal A value would be 1. That's kind of like the parent A value, if you will. And we're shifting the vertex left 5 and up 2. Okay. But that's not what the question's asking. The question's asking us for the focus and, or just the focus actually. What's the focus? But I'm going to also find the directrix too. Alright, so once we have it in this format, we want to start thinking about our P value. And our P value here is going to be, if we're dealing with a parabola that has an X squared term, to get our P value, we're going to be looking for the X squared term to be by itself, and then the P value will be sort of extracted or calculated from the coefficient of whatever Y is. Alright, so let's try to get X squared, the X squared term by itself. And let's see, let's take the +2 and bring it over here. So let me get this out of the way for a second. So let's take the +2 and bring it over here. just subtract that from both sides. And now I want to get this to be a 1. I want to make that a positive 1. To do that, of course, I'm going to multiply both sides by negative 2. So multiply both sides by negative 2. And when I do that, I get negative 2 times the quantity y minus 2 is equal to quantity x plus 5 squared. And believe it or not, that is in the format x squared is equal to 4p times y. Even though those parentheses are there, it doesn't really matter. What matters is that this right here is a 1, a positive 1, and this right here will give us our p-value. Now our p-value is not negative 2, but again, as you saw in the last video, this is equal to this. Those are the sort of the coefficients of our y term. So 4p is equal to negative 2, so p is equal to negative 1/2. Now, that p-value is extremely important. That tells us the p is the distance that the focus and the directrix are from the vertex. That's a really important value, that p-value. It tells you how far away the focus and the directrix are from the vertex. So we need to go up to our graph and think about our focus and our directrix being 1/2 unit away from our vertex. So what I'm going to do here is kind of zoom in a little bit and get a better close-up idea here of our graph. So our p-value is negative 1/2. That means that from this vertex right here, your focus is 1/2 unit down. Remember, your focus is always going to be inside of your parabola, and your directrix is always going to be up here. So your focus is, and remember your vertex was negative 5, comma 2. So your focus is going to be 1/2 unit down. So it's going to be right in here. That's going to be your focus. And the coordinates of that point are negative 5, comma, it's 1/2 unit down from your vertex. The up and down, of course, is your y coordinate. So, well, think about it. What's 1/2 unit down from 2? Well, that's easy. That's 1.5. So your focus has coordinates negative 5, comma, 1.5. Now your directrix is in the other direction. Your directrix, of course, is up the same distance away from your vertex, 1/2 in the other direction. So your directrix is going to be a horizontal line right here, and that's going to be y equals, this is our directrix, y equals 2 plus 1/2. So y equals 2 and a half. We'll just call that 5 over 2. It's 2.5. So there you go. That answers the question. Your focus is negative 5, comma, 1.5. Cool. Here we go. We'll go to another example. Write the equation of the parabola with vertex at 0, 0. And focus at 0, comma, 4 over 5. So let's put our vertex in there at 0, 0. And we'll make this positive 1. We'll make this negative 1. And our focus is at 0, comma, 4.5. That would be about right here. Call that point F. And your directrix, of course, is in the other direction, which would be down here. That is y is equal to negative 0.8, or negative 4/5. So your parabola, if you wanted to graph this thing, would look like this. It would be symmetrical, which is a little tricky to draw here, but that's not bad. And we need the equation of it. Well, we know that the equation of it is going to be something along the lines of y equals x squared. That's the general sort of format. But as you know, there is a p-value that we have to calculate. So we're not going to use y equals x squared. We're going to use 4p y equals x squared. Because we already know our p-value. Think about that. Our p-value is the distance between the vertex and the focus, and the vertex and the directrix. And in this case, it's 4 over 5. So what you do is you go over here and you say 4 times our p-value. Our p-value is 4/5 times y is equal to x squared. Well, this is 16 over 5. Y is equal to x squared. We want to get y by itself. So y is equal to, we're going to multiply both sides by the reciprocal of 16 over 5 and get this as our answer. And that is the equation of the parabola that has a vertex at 0, 0 and a focus at 0, 4 over 5. It's all about that p-value. The p-value is extremely important. Let's try this one. Vertex at 0, 0. Directrix is given this time as the line x equals -3. Alright, so vertex at 0, 0, that's right there. X equals -3 is a vertical line at -3. And our job is to, I guess, find the equation, right? The equation of this parabola. So, first thing I do is, let's just draw in my focus just for fun, see if we can figure out where the focus is. If the directrix is 3 units away from the vertex, then that means the focus is also going to be 3 units away. That's our focus. Our focus is 3, 0. Remember, your p-value is the distance that your focus and your directrix are away from your vertex. So the focus is always on the inside, so this parabola is going to curve like this. And when it curves like that, you know it's of the form x equals y squared. That's the general form of sort of the parent parabola that is situated at the origin and facing to the right. But of course we want to find the p-value, so we do this. 4p times x is equal to y squared. And for the record, in the general form, the p-value would be 1/4, right? Because that turns your coefficient of x into 1. Alright, but this is not the normal parent, sort of, if you will. This is a bit skewed, and it's different by that strange p-value. So we already know what the p-value is. It's the distance between the vertex and the focus. It's 3 units. So we plug that in. We get 12x is equal to y squared. So x is equal to 1 over 12 y squared. And that's it. That is our answer. That's the equation of the parabola that has a vertex at 0, 0 and a directrix at x equals -3. Cool. And I guess I'll stop it there. It's about 27 minutes. So in the next video, we'll tackle a few more examples and we'll go from there. All right, thanks.